Ooh. We'll start by talking about the test details. So what I'm looking at right here is in the content library. So the test is 8 total questions. Should be able to multiply complex numbers in standard form, divide complex numbers in standard form, convert between standard and trigonometric forms, or vice versa, multiply complex numbers in trigonometric form, divide in trigonometric form, do powers in standard form and roots in trigonometric form. In all these questions, like, I might be specific about how I want you to format your answer. Like, even though your problem, stop talking please, was in trigonometric form, I might ask for an answer in standard form or vice versa kind of thing. So like, there could be some conversion kind of built into some of these problems. You get what I'm saying? Just like we had on the problem sets and stuff, like, not surprising, but I want to make clear that, like, you definitely need to be able to convert back and forth between things because you might have to do it a lot, which is okay, not a big deal, but again, you should know. But that's it, like, pretty straightforward, not a lot to talk about there. Questions about test format or anything like that? Okay. Last time I had scarily assigned up to 120. Are there questions on homework stuff that we want to talk about? Emma, we'll start with you. 7-7. Shoop. All right, says find the cube root for the indicated numbers. Leave your answers in exact trigonometric form. Okay. Emma's talking about 27, or I'm sorry, 77. 27 was the coefficient there. So just applying de Moivre's theorem. So I have cube root 27 cosine of 2 pi over 3 plus 2 pi k over 3 plus I sine, and then I'll copy it the same way. Now this is kind of gross looking because I have this like fractions inside of fractions kind of thing, but that's fine. I'm just going to leave it this way and we'll clean it up in a minute. Cool there? All right, so I have 3 answers for when k equals 0, 1, and 2. When k equals 0, I basically just have 2 pi over 3 divided by 3, which is 2 pi over 9. And notice that it asks for an exact answer in trigonometric form, so I don't want to convert that to a decimal. I'm going to leave it a fraction in terms of pi. Cool there? Okay. When k equals 1, I'm going to have 2 pi over 3 plus 2 pi. So that's going to give me 8 pi over 3. And when I divide by 9, I get 8 pi over 9. I think. And then when I add 2 pi, add 4 pi when k is equal to 2, right? 2 times 2 pi is 4 pi. So when I make a common denominator, that becomes 14 pi over 3. So divide by 3, I get 14 pi over 9. I think that'll do her. Does that feel okay? So again, I want to point out to you, like, look at the pattern going on here. What do you see? Numerator's going up by 6 each time. That's a good indicator you did things correctly. In addition, if I look at the last one, that's less than 2 pi still. If you're using 0, 1, 2, all your answers will be all your angles should be between 0 and 2 pi, assuming that you had an angle between 0 and 2 pi that you started with. But Mackenzie, which one? 87. Sure. Emma, you happy?
Yes, thank you.
Yeah, no problem. $87. So we want to do the cube root of these guys, and they want their answer back in standard form. I think the answer in the back of the book is wrong on this, just flat out wrong on this one. Yeah, but we'll do it. So the first thing I'm going to do is find my value for r. So negative 4 squared plus 4 squared gives me square root 32. And I guess if I wanted to, you can call that 4 root 2. That's fine. Either is okay. Probably just leaving it this way is going to be more convenient. We'll do our theta then. So if I plot this, negative 4, 4 is like over here. So my theta is going to be 180 minus tan inverse of 4 over negative 4, or absolute value 4 over negative 4. That's just going to be 135. So my z in this case is square root 32 cosine 135 plus I sine 135. Sup, dude? Kid's always late for class, right? No, nobody thought that was funny. Okay, keep moving on. Evan Oak. Oh, yeah. Seems like he pokes his head in here about the same time every day. All right, Mackenzie, so far so good though? Yeah. Okay, so now we'll do the cube root. So the cube root of the square root of 32 times cosine of 135 plus 360k over 3 plus I sine, same thing. And just for the record, I chose to do this in degrees. The question is asking for a standard form answer, so I'll convert this all back out to standard form at the end. You could have done it all in radians too if you wanted, but like, who cares? Who cares? That's just what I chose. And again, for k equals 1 or 0, 1, and 2. So for k equals 0, we have the 6th root of 32 times cosine of 135 divided by 3. What is that? Is it something? I don't think it's something, is it? It's 45? Of course it is, Mr. Kulik, you dummy. Sorry, Mackenzie. I knew that. Okay, with k equals 1. And I'll do the conversion here all at the end. I have 135 plus 360, so that's 495. I divide that by 3, and that's something, 165. And then my last one is going to be 6th root cosine of 285, I think. Yeah, I thought so. And then we're just going to convert these all out to standard form values. So I'll do the 6th root. So I'll press 6 and the math button and then grab option 5. That'll make a 6th root, 32, times cosine 45. Just double check that I'm in degrees. I am, okay. And then I do the same thing for 165. And do the same thing for 185. Okay, so let's write those down real quick. 1.26 plus some stuff, negative 1.72 plus some stuff, and then 0.46 minus some stuff. And then we'll just do the same thing now with signs, right? So scroll back, oops. Sine 45, boop, boop. Sine 165. 5, whoop, whoop, and then sine 285. Wowzer, wowzer, yowzers, look at the pattern there. That's pretty neat, huh? So I have plus 126i, and then I have plus 0.46i, and then I have minus 172i. So those should be your actual answers there, Mackenzie. Is that what you got?
Yeah.
That's because you're smart.
No, I actually.
Well, that's great. It's pretty cool when you can not know what you're doing and still get the right answers. You know? My apologies about the answer keeping incorrect on that one. But if it's like 1 out of 120 that you goofed, it's not just one, I think. But if it's like 2 out of 120, that's still pretty good. You know? A lot of it's just copying errors or whatever. You know, like you copied the problem down wrong, you got solved the wrong thing. You know what I mean? Just because you're dumb. Make dumb mistakes. It happens. Who's next? Okay. Oh, Drake.
One quick question for like the first half, like, especially the first half of the powers. Are the book answers correct, or is it like the same situation as 11-ish to homework where it's just like had an alternate?
Which one are you guys talking about?
Like, take for example, that like number 65.
Okay, so in the directions on 65, it's saying very specifically how to write your trigonometric form answer. So it wants it with the angles between 0 and 360. So there's lots of equivalent answers that you could have, but you'd have to coterminal things down so that you fit the directions. So that's why the answers in the book may not match the answer you have. You may still have the correct answer, you just need to like convert your angle to something coterminal.
Trigonometric form is 32 while I have 32 outside of bracket.
Oh, it just might be a typo. This one, like 2 to the 4th should be 16 instead of...
Yeah, well, I have 16.
Yeah, that's okay. That got goofed. Probably just goofed. Okay. Anybody else?
Did you do 68?
Sure. So De Moivre's theorem, I'm going to have 2 to the 6th. Cosine 6 times negative 118 plus I sine 6 times negative 118. 2 to the 6th is 64. 6 times 118 is 708. Oops. And then I just have to convert that into something between 0 and 360. So if I add 360 twice, I get 12 degrees. Negative 708. If I add 360 twice, that'll get you to a positive angle. Yeah. Like back to first semester. Paul, you happy? Okay. And which one? That was 68. I guess I didn't write that down. Okay. I'm going to get out of your way. It's review time. Knock out some of the homework or the review pack or all that. If you have questions, feel free to come on up. I'll deal with individual questions as they come. Sound good? Okay. Get to work! As a joke.